Hey, good morning, sixth graders. So I'm going to go through 5-9 with you. I really think that you guys are really good at 5-9, actually, because it's a lot of operations and in ordering pairs and that kind of stuff. So PEMDAS, you guys remember PEMDAS pretty well. Please excuse my dear Aunt Sally, or parentheses, exponents, multiplication, division, addition, subtraction, right? And we know that we do these and these together from left to right, moving that way. So parentheses, exponents, multiplication, division together, addition, subtraction together. And what I mean by together is we don't start with multiplication. Like I wouldn't skip into multiplication over division. If division comes first, left to right, then I take the division, right? Okay, so that's what we're going to talk about, and it's going to be really brief because I know that you guys are really good at this. But for those of you that are struggling, here's your second opportunity. So we solved all of this in our math notebook already. And so I'm just going to go through a few parts of each section. And if you want the answers for those, well, one, they should already be written in your notebook. But two, you can just message me and I will go through them with you. So number one, 16 by 2 plus 6 times 3. We start with parentheses. I don't have any parentheses, and so I'm going to move on. Parentheses, exponents, I don't see any exponents. Now I have multiplication, division. So I see division first, and so I'm going to do this 6 divided by 2 first. 6 divided by 2, 16, sorry, divided by 2 is 8, plus 6 times 3 is 18, right? And 8 plus 18 is 24. I'm sorry, 26. My pen's working. I always forget that this part of my screen up here at the top doesn't work. So I just scoot it down a little bit. Okay. Same thing, I can use the distributive property on this, and I can do 7 times 5 plus 7 times 4, which is 35 plus 28. Or I can just do 5 plus 4, which is 9, because that's what's inside the parentheses, times 7, which is 63. Just for fun, 7 times 5 is 35. 7 times 4 is 28. Let's see, 35 plus 28. 8 plus 5 is 13. 3 and 2 is 5 plus 1 is 63. Okay, I would have gotten the same answer using the distributive property. Just thought I'd share. Number 3, we're going to start with exponents. Right, so 3 times 3, not to be confused with 3 times 2 because it's not 3 times 2. Exponents means that we expand into products and factors. So this product is going to be 3 factors, x times x times x. And in this case, 3 to the second power, or 3 squared, it's going to be 3 times 3, which is 9, plus 3. 9 plus 3 is 12. All right, 12 here. Okay, so these obviously, they get more complicated as you go. 4, 5, 6. I'm going to leave those blank for now. You should have them written in your notebook. If you want to try them on your own, go for it. The answers are, and I'll just write them down here in green. 1, 49, and 44. Let's move on. Okay, so it says evaluate each expression for x equals 3 and y equals 5. So when x equals 3 in number 7, that's 4x minus 6. What that really means is, I'm going to zoom up on this. I have more room to work. 4 times 3 minus 6. That part of my screen just does not work. I don't know why. So now I can just work left to right. Do I have any parentheses? Yes, but there's nothing I can do inside of that parenthesis. So now I need to move to multiplication and division. When numbers are next to each other like this, that means multiplication. So 4 times 3 is 12, minus 6 is 6. So 6 is my answer. Moving on. 15 divided by y minus 4. I'm going to solve what's inside of my parenthesis. Well, first I need to rewrite this to make sense. 15 divided by 5 minus 4. Right? And I know that this y is 5 because it tells me right here that y is equal to 5, right? Okay. So I'm going to start with what's inside of my parentheses, which is 5 minus 4. 5 minus 4 is 1 divided by 15. Sorry, that was bugging me. 15 divided by 1 equals what? 15, of course. So I'm going to write 15 in my answers. Okay, number 9. This one gets tricky because I have to substitute twice. So I'm going to put 10. Y is 3, right? Oh my goodness. Plus, and I think this is, I remember I have to go over and look. Oh, y equals 5. This is 3. Oh my goodness. 10, 5 plus 3 squared. Okay, now I can solve this. Do I have parentheses? Yes, but I can't do anything inside of this parenthesis, right? Nothing can happen. 5 is 5. Then I move on to my exponents. 3 times 3. 3 times 3 is 9. Plus, now I can simplify this. 10 times 5 is 50. 59. Anytime I write in that part of the screen, it just takes me out. Okay, so like I said, whoops. The rest of this section can be done in your journal. The answers, I'll give you the answers in green. 30, 64, and 23. If you can mark those and come up with the right answers. Okay. So now we're going to write 2 equivalent expressions to represent the number of dots in the drawing below. Remember, each of the yellow sections is worth an unknown value, and we're calling them D dots. We don't know how many are there, but we know that this box and this box have the exact same amount because D is D. D is equal to D. So we can write this a few different ways. We can do D plus D plus 3. It's doing it again. Sorry. We could do D plus 3. Or we could do 2D plus 3. We could also do 3 plus 2D, right? Using the commutative property addition, switch those around. Good. And number 14, same deal. This is tricky because they're taking away. And what does take away mean? Take away means minus. So we're taking that box away. So originally I have 3 Ds, right? And then I subtract a D. And then I add 2. Right? This could also look like, you know, I could pull these. I could pull those right out. And it could look like this. B times 3 minus 1 plus 2. That's an answer that I could have done. See what else you could come up with. So, this is evaluate for one of, if your expression is D. So, or, I'm sorry, if D equals 12. If D equals 12 here, we just plug in the equation, right? So 2D plus 3, which is 2 times 12 plus 3. 2 times 12 is 24. Plus 3 is 27. See if you can solve that for the other one. I'll push pause. Or go ahead and push pause on the video. Okay, now that you've tried it, 20 is the answer. We got 20 because B is equal to 9. And I have 9 times 3 minus 1 plus 2. 3 minus 1 is 2 times 9 is 18 plus 2 is 20. 20 donuts. All right, on to the next page. You should be on page 200 now. This is a lot of what we've already been doing for each expression. Describe a situation and make a diagram. Then circle the equivalent expression. Okay, so we talked about unknown numbers and using them in word problems. I'm going to do number 15 for you, and I'm going to leave number 16 blank. And I'm going to give you an opportunity to work on that. Like I said, this should be in your math journal. We've gone over this, and I hope that this is helpful for your homework tonight. So 4x plus 2. Maybe I'll type so that you can actually read the writing. So we said in class, Jeremy has 4 boxes of donuts. Oops, boxes. With an unknown amount of donuts. Box. Then adds 2 donuts. Then he adds 2 donuts to the total. Change this so that you can see that this wasn't the book that wrote this. I wrote this. It should stand out, so I'm going to write it in. Green is fine. Okay. Now we need to make a diagram. And the diagram looks something like this. We have unknown value here, unknown value here, unknown value here, and another unknown value. Plus 2 more donuts. So we have 4 total unknowns plus 2 extra donuts. I keep wanting to go over there, but I don't know why. Okay, so circle the equivalent expressions. Remember, equivalent means equal. Which of these expressions is equal to what we have going on up here, right? So 6x won't work because we only have 4 total x. That's our unknown value. We only have 4 of those, so that won't work. We do have 1, 2, 3, 4 unknown values. This is about the same about the same. That's not what I meant to say. This is the same as 4x. So that'll work. And of course, the 6 plus x won't work either because we have more than 1x and we have more than, at least more than, well, never mind. We have 2 donuts, not 6. That's what I meant to say. Okay, so go ahead and do number 16 on your own. We did it in class. See if you can come up with another one. Circle the expressions at the bottom. If you have any questions about number 16, just send me an email or hit me up on Teams and I can help you through it. But you'll have another opportunity to practice on the homework and remember tonight. Okay. At a restaurant, Maria and Sam each paid $D for their food and each left $3 for tip. So draw a diagram to represent the total amount that Maria and Sam paid. So they must have paid the exact same amount because it says they paid $D, and $D is how much he paid and how much she paid. So I don't know why I did that highlight. So draw a diagram. So Sam paid D and Maria paid D. And then they each did 3. Right? So write 3 different equivalent expressions. We could do 2B plus 6. We could do B plus D plus 3 plus 3. Right? 2 for Sam, 2 for Maria. We could also Sam paid $D plus 3 and Maria paid B plus 3, right? That'll work. Okay, so all about math is figuring out how are you going to use math in real life. And math, you have to be able to take the numbers and how you know how to work the numbers and work them into real life situations. And so this is like kind of what we're building up to. I need you to be able to write these expressions in real world situations. So Fatima made M batches of 12 muffins. Her children ate 5 of the muffins. Write an expression for the number of muffins that were left. So we don't know how many batches, but we do know how many is in each batch, right? And if they ate 5, well, then the equation would be pretty straightforward. It would be 12 times M minus 5. Because they had 12 muffins. We don't know how many total that is, right? But we do know that we have to multiply 12 times M, or 12 times how many batches. Because if we knew that it was 2 batches, we would go, oh, 12 muffins times 2 batches, that's 24. And then they ate 5 of them, we're left with 19. But we don't know that information. We can only write down what we know right now, and that is 12 times the number of batches minus 5. Okay, so let's pretend that M equals 4, and so there are 4 batches, 12 per batch. They ate 5. Well, 4 times 12 is 48, right? I'm going to write that down somewhere so we don't get confused. 12 times 4 minus 5. 12 times 4 is 48 minus 5 equals 43. That makes sense? Okay, Number 19. Rebecca had $47 in her savings account at the beginning of the year. Then she added $6 a week for the next W weeks. We don't know how many weeks. Write an expression for the number of dollars in Rebecca's account after W weeks. So this is really useful in real life because when we're predicting like a budget or we're predicting how much we're going to make, we can actually interchangeably use this. And so we can say, oh, what will happen if we use this in 6 weeks? Or what will happen if we do this in 9 weeks, you know? So let's write the expression. And the expression would be 47. Oops, I need to put first. 47 plus $6 per week. So I have this to begin. I have 47 to begin with, and then I add $6 for every week. Right there. No, sorry, I'm just going to leave that as the expression. I'm going to move on. If we do this for 20 weeks, now we have an expression that looks like 47 plus 6 times 20. And I know that 6 times 20, I can simplify that. Simplify means to put together, right? 6 times 20 is 120. And 120 plus 47 is 167. So she'd have $167 if she did that same pattern. I don't know why I'm doing that again. Sorry. She would have $167 at the end of that 20 weeks if that pattern was consistent. Okay, moving on. Dale had a square piece of paper with sides 6 inches long. He cut out a square with a side length of S inches. Write an expression for the area of the paper that was left. Okay. So we're going to use this in our geometry, right? And we've already written this into our book. My answer looks a little wonky, so I'm just going to double check real quick that that's correct. Okay. So it's going to be 6 squared. Whoops. Here I am. Where did I get that 6 squared from? Well, he had a square with 6 inches that was 6 inches long. And what do we know about squares? We know that each side is the same length. So if this side is 6, then this side is 6. That's just how these work. And 6 times 6, well, that's 6 squared. Right? And he cut out a square with a side length of S inches. So there's another square, but we don't know how long those sides are. So that's how we do, squared, right? S squared. I don't think it's plus though, I think it's minus, right? Let's reread the question just to make sure. Dale had a square piece of paper with sides 6 inches long. He cut out a square with a side length of S inches. Write an expression for the area of the paper that was left. And yep, I'm pretty sure that's subtract because he's cutting it out. So when the side length is 3, the expression then becomes 6 squared minus 3 squared, which is 6 times 6 is 36, minus 3 times 3 is 9. 36 minus 9 is 27. Okay. So now we get into properties and equivalent expressions. And remember, an equivalent expression is just this is equal to this, right? And we've done these before. We've already done these. This is not new material. So I'm just going to do a couple for you. So this is asking, are these expressions equivalent? Yes or no. So the first one is obviously no. That's no because 3 times 3 is 9, and I don't see any 9 in this, right? Number 22, 6b plus b and 7b. Well, yeah, if there's 6 b's and you add another b, you're going to get 7. So the correct answer is going to be this. So 4m minus 4 is m. Well, nope, because I can't subtract these. This expression cannot change. I can't take 4 from 4m. I can take m from 4m, but I cannot take 4 from m, right? So that's a big fat nope. And then coming over here, 5 times a plus b is 5a plus b. Close, but nope, because this has to distribute to both factors. It has to go to 5a and 5b, right? Okay. So this one, all you're going to do is you're just going to simplify. I'm going to do number 25 and 26 for you, or with you. Number 27 and 28 you already have written in your notebook. So again, hit me up with questions if you don't know. Okay, so let's just start by looking at the x's. So it looks like I'm going to color code these for you because that's how my brain works. Here are all my x's. Here are all my not x's. I need to combine the greens and I need to combine the yellows. Not to the greens with the yellows. I need to combine the yellows and the yellows and the greens and the greens. And so that's what I'm going to do. 6 and 1 is 7. Plus, I have 4x plus 2 times 7x. Well, 2 times 7x is 14x. Right? And then when I add 4x to it, I get 4x plus 14x. Well, 4 plus 14 is 18 x's. Right? And that's what I'm left with. I have 7 plus 18x. And that's the correct answer. Circle that. So that's what our answer is. Okay. Let's see if we can do it without color coding. I have n's and I have m's. Actually, I said we weren't going to color code, but here we have color coding. Just going to do the rest in purple. Okay. So I have 2 m's total, 1, 2. And then I have 2 n's here and 3 n's here. That's 5n. 2m plus 5n. I can't simplify anymore. It's just what it is. Done. Circle my answer. Okay, yeah, I'll do number 27 with you because this looks a little tricky. Okay, so same deal. We're doing the exact same thing. I'm just going to underline. I have y's and I have non-y's, right? These actually, this is one term because it's a product, right? Okay, let's start by rewriting all of my y's on one side. I'm just going to go 3y plus y. I'm going to put parentheses around it just so that it helps me distinguish that that's separate from everything else. Oh, I didn't do this right. Because my pen's won't work. This is an entity. We did not start by defining our terms, and that's a big no-no. So let's try that again. I have my y's, and I have my non-Ys. And the reason that I highlighted these the way that I did is because that's how we identify a term. This is a term because it's separated by these, addition or subtraction, right? This is a term, this is a term, this is a term, right? Now I can start simplifying. 3y times 3 is 9y plus 4 times 4 is 16 plus y plus 10 times 2 is 10, right? Okay. Now I can take it to the next step and I can rearrange using the associative property. 10y over here, 26y, or 26 over here. So now I've got 10y plus 26, right? 10y plus 26, circling my answer. Good. I'll do number 28 with you too, because this is also tricky. So what's tricky about this is our exponents, right? And if we do PEMDAS, we're going to do what's inside the parenthesis first, which is 6. Hold on a second. I need to change the size of this pen. It's driving me crazy. So 6 squared plus 3x plus 2x plus x. Can I combine these x's? You bet. If I have 1x plus 2 more x's and then I add another 3 x's, I have 6 total x's, right? Plus 6 times 6 is 36. I should have told you guys to start with this. I apologize. I should have told you start with this, but it didn't really matter. In this case, it didn't matter. But in the future, you really should start with your exponents and then work your way towards multiplication and then addition and subtraction. I apologize. But just know, I did it wrong and I got the right answer this time, and that could happen to you too. So just keep that in mind. So let's rewrite our answer. Our answer is 6x plus 36. Let's circle my answer. Okay. Let's move on to number 29. It's asking us to use the distributive property to write an equivalent expression. So this should be pretty simple because we just practiced this, right? What are we taking out of here? What's the greatest common factor between 5 and 15? Yep, 5. And then I'm left with x. Oh, not plus. I'm sorry, minus 3. And I know that this has to be 5 and 3, right? Because this is 5 and 1. You can hardly see that, so I'm going to explain that in greater detail. Okay. So, zoom in on this. Okay. So I can break these numbers into 5 and 1, or x, 5 and 1x, and 5 and 3. I'm going to pull these 5s out and I'm going to put them right here. Then I'm left with x minus 3, which is this. Okay, that's simplifying or rewriting an equivalent expression. You can do the same thing over here. And I'm going to, I can pull a's out. Ooh, I don't think I like that. Yeah, I don't like that. No. Sorry, guys. Okay, now I'm left with a times b plus c. Can I rewrite an expression here? Yep, I sure can, because this 2 can be distributed to this p and this 7 to get 2p minus 14. I'll let you guys do 31 through 34 on your own. Go ahead and pause the video. Okay, the answers for this are 4y. I don't know why it's doing that. 4y plus y squared. Moving on. X squared minus 10x. That's x minus 10. And RP plus 3R. Okay. Okay, so we're going to practice this again. This is where we're pulling numbers apart step by step. Greatest common factors of 42 and 35. The greatest common factors between 42 and 35 are, looks like 7 and 6, and 7 and 5. The reason that I pulled these apart is because I have these 7s that are the same. And I know that 7 times 6 is 42 and 7 times 5 is 35. So now I can rewrite these. I'm going to get real close on this screen. So 7 times 6 plus 5. Did I do that right? Hold on. Let me check. Yep. My 7s. And then I added 6 and 5. Well, 7 times 6 plus 5 is 7 times 11. Which is 77. 42 plus 35 is 77. Okay, same deal. What's the greatest common factor between 36 and 48? The correct answer is 6. So I'm going to write 6 and 6. 6 times 6 is 36. 6 times what is 48? 6 times. Oops. Six times 8. And I know that because double, double, double. 6 plus 6 is 12. 12 plus 12 is 24. And 24 and 24 is 48. Oh my gosh, I keep trying to move my screen with the pen selected. Okay, so now I need to pull out my 6's, right? So now I have 6 times 6 plus 8, which is the same thing as 6 times 8 plus 6 is 14. Okay, and that does it for lesson 9. Remember, your assignment will be posted today. If you have any questions, you just have to email me, or just we could set up a Zoom appointment. You just have to let me know that you have a question, okay? And with that being said, I will stop recording. Have a good day, guys.